Hello viewers, Alan here. So in this project I want to create a fixture which will help me solve a problem I've got with another project. What I need to be able to do, this is for a drill sharpening jig I hope, but it's got compound angles on the front here and I need some way of holding this workpiece so I can mill those angles. So I've got to cobble something up really. I've called this project a compound angle jig, and I suppose, or fixture, I suppose that's what it is. But because it's a means to an end for another project, I don't want to waste any time or effort, more time or effort on it than I need to. So I had a look at what I had available to me to use, and that's the start point. So I need to be able to rotate whatever it is that I make. And so this thing here is the mounting plate from the bottom of a milling vise, so that will give me rotation. This thing here, this big plate, might be familiar to some long-term viewers. This is something I made to allow me to, it's a crude sine table. These fixtures here allow it to be fitted onto the milling table, and then these bars act as sine bars to tip it to a particular angle. So that gives me a tilt in one direction to add to the rotation. But I also need to be able to actually fit this onto that table. So I've got a bit of plate here, somewhere you can see a bit of it here maybe, which will be a base to fit on there, and then this thing will fit on that base. I've got another bit of 16mm plate because I've got to make some more of these things. So let's get into it. Oh, and I should say I don't have a complete design for this thing. It's very much make it up as I go along. So the video could be a little bit disjointed as I backtrack and and ah. But let's get into it and start making some chips. So I've designed the pivot blocks to be 14mm thick, 52 long I guess, and 30 high. And I cut two blocks out of this offcut of 16mm bar, I think it was actually, anyway whatever, 16mm mild steel. And they're sitting there in the vise at the moment, waiting to be brought to height. They are already correct length and correct thickness. This operation will bring them to correct height. So the blocks currently are at 32.4 as you can see, so I've got to take 2.4 off. So I think I'll try a 2mm depth cut, see how that works out. To make sure these two blocks finish up the same height, I'm doing the final finishing operation for the height with a pair of them wedged in together, so that's going to guarantee they come out the same. Well, I didn't get a complete clean up on that final pass. There's a little bit there that's undersized. The 30mm height for the blocks is nominal, so I'm going to sacrifice achieving that target to clean this up. We'll probably finish up about 29.9 or something. That's cleaned that up nicely, and that was more important than sticking to the 30mm nominal dimension. So I'll pull them out of the vise and do a final check on the sizes that I did finish up with. So I did finish up 0.13 undersize on the height. Like I say, I don't think that's a big issue. We're shooting for 56 for the length, well, hit that pretty well, and shooting for 14 for the thickness. That's close enough. So now I have my two blocks to size, so I've got to drill some holes in them. So I've finished drilling the vertical holes in these two blocks. It was a 6mm hole, 10mm counter bore, and I used a 10mm end mill, so I just needed to skim the head to the bolts to make sure they were a nice fit in there. The one on the end here, the screw won't drop through. It's still set with the same recess for the head, but the bottom half of the block is 5mm for an M6 thread, so that's the next thing to do. So I decided to cut the thread from the other side because it comes right through to this side but starts about 15 down from the other side, so I'll see more of the tap. But another thing anyway, I needed to turn these blocks over because I'll be milling a recess across the full length to make sure that the part of the face that contacts the plate that it's being bolted to is along the two long edges. That way it sits solidly on the plate and won't rock. Well, that's the plan anyway. It's a simple thing to do, but it's something I worked out when I was putting a DRO onto another machine to make sure the blocks would not rock when they were bolted up to the cast surface. Right, next one. So I'm setting up now to drill the cross holes for the pivot bars. So that needs to be a 1/2 inch diameter hole, which I'll ream. So I'll start off with the centre drill just to accurately mark the location of the hole, then take that through with a 31/64 drill to get within a, what's that, 15th thou or something of size. So rather than using the Inox MX3, I think I'll switch over to using something that's actually designed for it. It's probably better. And then take my 1/2 inch reamer through it. Well, let's show it a 1/2 inch dowel pin. It's a bit of a press fit actually. Well, the dowel pin's right on size, and this is the material that I want to fit in the hole, and it's a hair under 0.5, so it might actually be quite a nice fit in that hole. So I think I better try the actual workpiece in the hole just to satisfy myself that the fit's going to be okay. Oh yes, nice, that's exactly what I was looking for. Setting up now to cut the slots for the clamping action, and looking at it I'm thinking to myself, I might have made the top and bottom pieces of this too thick to actually bend with the clamping screw. We'll have to see how that works out, but I'm only doing a 1mm slot, and the clamping action isn't to stop rotation, it's just to take free play out, so provided I get any movement at all, that'll be enough. And I think, as you saw, the pivot bars are a good fit in the hole, so hopefully it'll be alright. When I've done these things before, I've started with the saw coming in from the side, so its first contact with the work is on the corner, and that always makes a horrendous grinding noise. So this time I'm going to try a bit differently. I'll come in on the face and work back towards me, and then in a little bit so that the teeth aren't contacting on the corner. Let me see if that works out any better. Now that's a 75mm diameter cutter, so I need to get the speed down quite a bit. I think I'll start off at 100 RPM and see what that looks like. Perhaps go up a bit from there. Right, well that's gone all the way through. Switch the blocks around and do the other one. So that's worked out fine, that's still a good fit on there, but even a slight nip on here, that's got it. That's all I need from that clamping action. So I have both of these pivot blocks to this state now, with all the holes drilled, the clamping slot machined, but I want to use them with this, reuse this plate. It has these notches or cutouts, and I want these to swing around the bar in those, but they won't fit with square corners. So as you can see with this one, I've actually machined off the corner. Now it's happy to swivel in the available space. So I'll just show you how I knocked those corners off. So I want to cut these vertical corners here at 45 degrees. To do that, I've been mounting them in this fixture, I suppose you'd call it, which is accurately cut to 45 degrees, and you can just perch things in there. Makes it easy. We'll load that into the vise. So using that angle block and my vise stop, I can get some repeatability in positioning these things, so I can do one side, knock that corner off, and then just turn it over and reuse the same setup. I have to come down 3mm, but I'll do that in several passes. 1.5, go back the other way at 2.5, and make the last pass at 3. So I'll clean those surfaces up with a file, then turn it over and do the opposite corner. So when I test fitted these pivot blocks, I found that one of them, in its notch in the plate, wasn't free to completely rotate as much as I wanted it to. When I checked carefully, I found that one of the notches was just slightly narrower than the others. Just a bit of backstory on this plate. I bought it with a pair of 4-inch vices attached, 4-inch milling vices. This is going back when I had my other milling machine. Anyway, this plate was made by some tool maker who fitted it up, and the outside edges of the plate are flame cut, and the notches that this attachment method is using, they were flame cut as well, and the notch over here is slightly narrow, so I've put the plate on the milling machine to open that notch up slightly. And that long ago tool maker, when he laid all his patterns out, carefully or thoughtfully left a pair of 8mm dowel holes, and I've used those with a straight edge to get the plate aligned on the table. So that alignment's close enough for what I want to do, because I just need to take about 0.5 mm off this side of this notch, and it's only about, I don't know, 15 or 20 millimeters long, and I used a 300mm length for the alignment, so that's going to be close enough. So because I'm cleaning up a flame cut piece of metal, I've put a 10mm solid carbide end mill in. So if I slip this in here now, yeah, all the space I need. Successful operation. So it's been raining pretty heavily today, but it just seems to have slackened off a bit, so I'm going to do a bit more recording of what I'm up to. I'm working on the base plate now. This is 16mm thick mild steel plate. I don't intend to go overboard with it. It has been wire brushed and scotch brighted, and that's it. I'm not going to machine the faces. It's going to be a bit rough and ready, because this tool that I'm making, this fixture that I'm making, likely only be used once, and it doesn't need to have a Rolls Royce finish to get that job done. So this is a flame cut edge, and it's actually surprisingly good, and I've picked that to be my datum, I suppose. Mounted the straight edge on it and run the dial gauge over, and got a pretty good setup, pretty good alignment. Don't know what was going on there, but it didn't sound too good, did it? So that poor old 10mm cutter was very unhappy when I asked it to do full thickness with a depth of cut of 0.5. But when I reduced the depth of cut to half the thickness of the plate and the depth of cut to 0.3, the sun came out and it was very happy. So I think what I'm going to do is finish this side off and use that as an edge to stand the plate on edge, and try to machine the other long side in a vertical orientation, and we'll see how that goes. But I've got to finish this side off first. Had coolant dripping off everywhere then, but I think we got the result we're looking for. That looks alright, it's cleaned that up quite nicely. When I was cleaning up the long edges, I was being really bugged by the amount of coolant that was running off the front of the machine. So when I set up to do the ends of this plate, the shorter runs, I decided to position the plate so that the back edge of it was well inside the catch zone for the apron around the base of the milling machine. But even with that, I had an issue with the coolant trying to run back off the front of the plate. So that's why you see that ruler there and the sticky tape. And that did prove quite effective at stopping the coolant from coming forwards and running off the front of the plate. So just a random little bit of extra footage here. The coolant's becoming quite mucky, so I decided to check on how my belt skimmer was going. It turns out it's working quite well, but the bottle that it was decanting the scooped up oil into was full, so it was just circulating it back into the coolant. So I've drilled and tapped holes for these bolts to secure the pivot blocks to the base plate, and as you can see, that is all lined up quite nicely. The table will be bolted to that, and so can swing like that. Now, just reminding us what we're trying to achieve here, I have to be able to, I don't know whether the camera's going to focus on this for me, but I have to be able to cut these compound angles here. To do that, I need to be able to offer this thing up under the milling machine with 3 different angles. That way, and I hope you can understand what I'm getting at. So I'll get the 3 degrees of freedom, shall we say, by 1 degree here, another one's the tip, and the last one is rotation on that. For anybody not familiar with this, these come with a milling vise. This allows you to rotate the milling vise on the milling table, but most of them live under the bench and never get used. But I thought I could use it in this situation. So, what I've been umming and ahhing about over the last couple of hours is exactly where to drill the holes in this plate to sit it on this swivel base. So I need a 25mm hole that this can rotate around, and that'll be a locating dowel, and then 2 bolts to clamp it down. That's taking a lot of pressure. I think I better drill a pilot hole. Originally I was going to centre this pivot on the centre line here, and I thought, well, I just realised that wasn't a very good idea. I'm better off actually centering that on the centre of the plate, because perhaps I should just point out that the table, which will sit on this base, comes out to about here. It's a piece of metal I had, so I'm just working with what I've got. Anyway, so I've changed my mind and decided to make the hole for this in the middle of this plate this way, and as close to that as I can have it, because it dawned on me that as the table gets raised up, the centre of mass all starts moving that way. Anyway, I've ummed and ahed about this for ages. I've got to drill 3 holes and get off the fence. I was much happier with a big pilot hole. When I do larger holes, the 25mm being an example, especially into thicker materials, I like to use annular cutters when I have one that's a suitable size. I don't have a huge range of them, and the largest one I have is 24mm. Sorry, the largest one I have is 22mm. So for this 25mm hole, that's what I'm going to use to get things started. I always remember Stefan Gottsweiler talking about these things. He said, most people over tighten things on milling machines. These things can't be over tightened. You do them as tight as you can, then a bit more. I don't have a 25mm reamer for some reason. I'll have to address that. But I do have a 25mm end mill, which when used in a milling machine is quite happy to identify as a reamer. So with any luck I'll have a 25mm hole there, which would be a good fit on that spigot. So checking the size of the hole that end mill made, I think you can see that it's 0.01 over the 25mm nominal size, which is perfect, because the dowel that has to go in that hole is just a hair under 25mm, so they should be quite a snug fit together. Now, time for the real test, whether the plate will actually fit on. Oh damn, it's heavy, I don't like this. Ugh. Oh yes, excellent. That's got quite a good fit. So getting ready now to put the table onto the base. If you haven't seen it before, I forget how much I've showed now. This is looking at the underneath as I made it originally with these pivot blocks. That shoulder there is designed to fit into the T-slots on the milling table. And then this thing pivots directly against the table and gets held up for the sine table action. Anyway, to get it on here, these blocks have to finish up like that, which means they've got to go like that. That one up. something like that. Get a couple of screws into that and snug them up. Right, well, let's see if we can wrestle this into position. I'm not sure whether this bolt is going to get in the way yet. That's something else to be discovered. And these pieces are heavy. Let's get these bits out of the way. Alright, somewhere near it now. So we can get a couple of these bolts in. And that's encouraging. Snip everything up. Right. Now this bit should lift up. Why is it stopping there? Looks like it's binding here. Let's do a bit more investigating. You have to excuse the puffing and blowing. I'm really not very fit these days. Moving these heavy things gets me wheezing, so I do apologise for that. I know it's not particularly nice to listen to, but that's me. Anyway, what's going on here, as I think you'll be able to see, there's not actually enough clearance just here. There was, if I wriggle this thing over a bit, yeah, there just isn't quite enough clearance on that side. It will go up, but it's actually lightly binding on the side here. So I'll just have to clean that out a little bit. But apart from that, it seems to be going all right. These bolts are too long though. This one in particular, you can see when I wind this up, it's pulling the bolt up. So now when I try and lay it down, it binds on the top. So I do have a plan to fix that. What I'll have to do is make a nut that fits inside the body of the turntable and then use a bolt down from the top. Then I won't have this bit sticking up. This one I don't think is a problem, but I might as well do them both the same anyway. So I've got to make a couple of big square nuts. I've sort of made now up to about as far as I've designed it. So now I need to work out how I want to support this at a given angle. And what I'm thinking is to use these blocks here. Put a bar, threaded bar up through there as props down to the base. It's pretty heavy. It needs to be solid. But I think that's a lot of progress. I'm very happy. So I whipped up a couple of square nuts with an M16 thread. Now it's actually quite good fun because I had appropriate tooling. It was a very easy job to do. So I used a 14mm rotary broach or annular cutter to punch the hole, and that was easy as. I was spinning that at about 170 RPM and it was happy as Larry. The tap I used has a spiral thread, a square drive, and I had an adapter in the NT40 collet chuck which was happy to drive the square shank, which made it completely effortless on my part. The machine was working, but not me. Doesn't get a lot easier than that, does it? I've tapped threads that size before by hand. Yeah, I'd much rather do it with the machine. So just to be clear where my 3 degrees of freedom come from, well, that's 1, that's 2, that's 3. When the plate's horizontal, that's the same as that, but when it's up at an angle, it's not the same. And those 3 different movements should allow me to position this at whatever angle I need to under the cutter head. Checking the sine bar aspect of this monster, I put my digital angle gauge on there. It's currently reading 0 degrees. It should also read 0 when it sits on the table, which it does. That's accomplished using a 10mm gauge block here. Because of the way the pivot geometry is, I couldn't get it to actually work on the table surface, so I deliberately did board the holes and everything to raise the underside of the bar exactly 10mm above the table. So now when I rest it down on the 10mm gauge block, I get the 0 degrees. So that aspect of things has worked out well, and yes, the gauge is working. So to make these table supports, I'm going to use a piece of this bar, which I've got a few bits of this lying around. It might have been dunnage or something originally, I don't know what it was. But it's yeah, about 25 by 20, something like that. So to improve the appearance of this scruffy looking object, I've cleaned all 4 longer faces, and I need also to clean the ends up a little bit because I need to use the edge finder on the ends so that I can find the centre of the bar for a drilling operation. So I've drilled 2 holes on the other side and tapped them M12 for the 2 pieces of threaded rod. On this side I have to cut a clearance notch 10 deep and about 30 wide. This is to clear one of the bolt heads that sticks up through the table. So that 12mm Kennametal end mill has done some really good work. We were going in 5 deep there, 12 wide. Alright, well let's open it out to 30 wide. So if my maths is any good, that's 9mm each side of centre line. It only has to be approximately 30 wide. Alright, well let's do the second pass. So that was the full 30mm at half depth, so I've got to repeat the exercise now at full depth. I mentioned earlier that I was driving a tap with a socket, a square drive socket, in an ER collet. As you can see here. I thought you might like a bit more information about that because they are so easy to use. They're made by Lisle, L-I-S-L-E. I think they're actually called tap sockets. And they come in, there's 2 different size sets, and you just slap them in the collet, and as you'll see, they're pretty darn easy to use, and when you have a lot of tapping to do, they're definitely a time saver. And put a squirt of goop on it, and off we go. And that's it. Right, all together now, so it should be pretty clear how it's supposed to work. Height adjustment from this threaded rod. Not the most elegant way to do it, but as I said at the start, I was working with materials pretty much to hand. I had a 600mm length of this, so I cut it in half and used that. I've reused the fixings that I made originally to attach the sine table, in brackets, to my milling table. What else? Oh yes, and I've put a line of holes in the base plate so that I can clamp this bar to the table and make sure it doesn't move. It wouldn't move if it was just standing on the table, on the bench, but with the vibration of a milling machine and whatever other forces it might put into the work and down through here, I wasn't going to take any chances of this slipping out of place. This lot's actually pretty heavy. This table piece here is 15 kilos, the base plate's 13 kilos, and this this milling base thing is another 10 kilos, so all up we're at nearly 40 kilos. Not a weight to be messed around with. But on the other hand, that weight's going to be, or mass is going to be a good thing, because it will certainly dampen out vibration. I was a bit worried about this being a bit too wanky and allowing movement, but I don't think it will, because when I've got this thing correctly set, I'll tighten down all of these pivot point places, and whilst they don't provide triangulation, I think it's sufficient with the rigidity of the plate itself to stop this thing from messing around. These two 16mm bolts will certainly hold this thing in place rotationally, and I've just done a mock-up of, why has that stopped turning? The bolts have gone tight, I think. Yeah, there was a tight spot for some reason just around there. In the nuts in this base there's a tight spot. Anyway, so using the drill sharpening jig as an example of how the table can be used, I need to mount this so this is horizontal, so I can run the milling cutter across, and I think you can see that being able to mount it like that will achieve that. And the angles that I calculated, the Euler angles to do that, the base needs to be rotated 25 degrees, this is rotated about 45 degrees, and the table here needs to be tilted 58.79. But to actually mount this on here, I've got to make some other bits and pieces, spacers and the like, and I haven't exactly worked out how to bolt this thing to that yet. But anyway, the purpose of this video was to show how I made this thing, and when I get back to my project for the drill sharpening jig, I'll be setting the angles accurately. Actually, one of the viewers who looked at the previous video, the first part of making this thing, was kind enough to say to me that he has one of these things, and that if I needed more info about it he would be able to supply it, which he has done. And it's the new info exposes that some of my guesses for these angles from looking at photos are reasonable, but others aren't. So I've got to go back into the bunker and recalculate all these Euler angles. Anyway, that's achieved the goal for this project, this video, which is to make a fixture for machining compound angles. And I need that for my drill sharpening jig. So I'm going to end this video here. Thanks for watching, hope you enjoyed it. And perhaps you'll join me for part 2 of the drill sharpening jig, where you'll see some chips fly. Cheers.